Well, we've broken through the first learning period of this semester, and now we're at the second. And welcome to Unit 3 of Geometry, and we're in Section 1 here. And we're going to talk about classifying triangles. Oh, what an acute triangle. Oh, really, don't be so obtuse. Well, this is some explosive information for you. The parts of a triangle. Triangle is a three-sided polygon. Triangle ABC, written with the symbol for a triangle with ABC after it, has parts named by the vertices A, B, and C. The sides of the triangle are segment AB, segment BC, and segment AC. The vertices are A, B, and C. The angles are angle BAC or angle A, angle ABC or angle B, or angle BCA or angle C. Okay, so an acute triangle has three acute angles. Remember, acute angles are all less than 90 degrees. So that's acute because small things tend to be cute. A good way to remember this is these are smaller angles. So all of the angles are less than 90. Now there is a very special kind of acute triangle, and it's called an equiangular triangle, and that means that all of the angles of the triangle are equal or congruent. Okay, our last type of triangle is called an obtuse triangle. It has one obtuse angle, one angle that is greater than 90. The other two angles must be acute. They must be less than 90. So because obtuse and obese, meaning fat, right, are kind of close together as words, that's a good way for you to remember that the obtuse triangle has a fat angle. Okay, the last triangle that we're going to have for classified by angles is the right triangle. And that's got one right angle. And that is always evident by this little symbol right here in the corner, the right triangle, little box that you see there. Okay, use the description to classify each triangle as acute, equiangular, obtuse, or right. So we can look at this first triangle here, and we can see that all of the angles are less than 90. So this would be an acute triangle. Triangle B, we have a 30-degree, that's acute, 60-degree, that's also acute, but we have a 90-degree angle. So that makes this a right triangle. Okay, so let's take a look at this. We have triangle PQR is acute, equiangular, obtuse, or right. So I have this entire angle here, right? And as it says right here, because of angle addition postulate. We can take those two measurements and add them together. So because the measure of angle PQR is equal to 45 plus 59, which is equal to 104, this is an obtuse triangle. Okay. Okay, so let's start talking about classifying triangles by sides. So first one we're going to have, we have three congruent sides, and that is called an equilateral triangle, three congruent sides. All three sides of the triangle are equal in length. Okay, isosceles triangle, that has at least two congruent sides. Isosceles translates from Greek, means isoskeles, equal bones. So just like your legs have equal lengths, that's the same thing with an isosceles triangle. Okay, it's got two congruent sides, equal lengths. Okay, our last type of triangle has no equal sides, no congruent sides. So you either have all three are equal, just two are equal, or none are equal when classifying triangles by sides. This is scalene. That's how we pronounce this, scalene. Okay, if M is the midpoint of segment JL, classify triangle JKM as equilateral, isosceles, or scalene, and explain your reasoning. Well, let's mark some things here. So if M is the midpoint of segment JL, that means these two pieces are equal in length. And since that's the midpoint, and this distance here is 1.5, I would divide that in half and find out that this segment here is 0.7.5. Well, because we have a tick mark here, because we have a tick mark, we have one right here, right? Let's highlight that instead. Okay, so we have this mark here, and we have this mark here, and we have this mark here. Those three are equal. So that means this one here is also 0.75. Well, those three sides are all equal now. So because of that, this is an equilateral triangle. Okay, find the measure of the sides of an isosceles triangle ABC. Okay, well, we can tell by the markings here and here that these two sides are equal. So we're going to use that information to set up an equation. So I'm going to set up my equation as 5x minus 0.5 equals 4x plus 1. So I'm going to subtract 4x from each side. And I'm going to get x minus 0.5 equals 1. Now I'm going to add 0.5 to each side. And I find out that x is equal to 1.5. So here's a good time to take out a calculator and do a little work, right? So we have segment AB, segment BC, and segment AC. I think AC is the easiest one to find because it's 4x, 4 times 1.5 plus 1. So we can just say with a calculator, 4 times 1.5 is 6. And then plus 1, that's going to be 7. Now the nice thing is once I find AC, I don't have to do anything to find BC because those are equal. So that'll be 7 also. So now I have to find segment AB. So I plug 9 times 1.5 and then I subtract 1. And I've got 12.5 once I plug all that into the calculator. And those are all the measurements. All right, this is an equilateral triangle, so let's do this because it's not marked, but I'm just take my word, it's equilateral. So go ahead and solve for y. Okay, well, there's a couple ways we can set it up. I can set these two equal to each other right here. I can say this one's equal, this one's equal. I can also go with these two equal, all right? And I think that's the one I'm going to go with because I think that'll be easier to do algebraically. So I'm going to set up as 3y minus 3 is equal to 2y plus 5. So I'm going to subtract 2y from each side. And I end up with y minus 3 equals 5. And I'm going to add 3 to each side. And I've got y is equal to 8. Yeah, we're not done. We've got another part to go with. Angles of triangles. The best angle to solve a difficult problem is the triangle. Okay, the sum of the measures of the angles of a triangle is 180 degrees. So every triangle, it doesn't matter. All the angles add up to 180. Okay, so what's an auxiliary line? Well, we draw extra lines or segments to analyze a geometric relationship. And you have to justify any properties of auxiliary lines that you have drawn, so you have to state certain things. So to prove this theorem, the triangle sum theorem, we need to use an auxiliary line. So here we have, given that triangle ABC, we want to prove angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. So we're going to superimpose here. We're going to put a auxiliary line, this one right here. And basically, because there's a rule in geometry that says through any point not on a line, which would be point A. Point A is not on line BC. There's exactly one line parallel to the initial line. Okay, so we can draw this auxiliary line, and it's going to say, hey, and make it parallel, right? So we would say, and we could call this line L for discussion, and we would be able to say that line L is parallel to line BC. We're making that statement. All right, so let's go back through some information we learned about parallel lines. And one of the things we learned is that alternate interior angles are congruent. So angle 1 would be congruent to angle 4. And angle 3 would be congruent to angle 5. So we're going to state that, right? We're going to say that angle 1 is congruent to angle 4, and angle 3 is congruent to angle 5, and that was by alternate interior angle theorem, right? Now, I can see, because we have a straight line here, I can state that angle 4 plus angle 2 plus angle 5 equals 180 by angle addition postulate. The next thing I can state, I can take angle 4 out and put angle 1 in. And I can take angle 3 out, angle 5 out and put angle 3 in. And that's by substitution. So we've proven this theorem. Now, I'm not worried about you doing the proof. I'm worried about you using the theorem. So the number one thing is what? The sum of the angles of a triangle add up to 180. They always add up to 180. Okay, so in addition to the 3 interior angles a triangle has, it also has exterior angles. And what that is just we take a line and we extend it. So we take the side of a triangle and we extend it out, and there's another angle that's formed. So you can see here, we've got our triangle ABC, and we've got angles 1, 2, and 3 in the triangle. And then outside of the triangle, right, we extended line AB, and we made a ray there, and it created angle 4, and that's in the exterior. Okay, now, the exterior angle has 2 remote interior angles. What does that mean? It's just the 2 angles in the triangle that are not next to the angle. So you can see angle 2 and angle 4 are right next to each other. So what this means is that angle 1 and angle 3 are the remote interior angles. They're away from angle 4. Okay, and so angle 4 is an exterior angle of triangle ABC. Its 2 remote interior angles are angle 1 and angle 3. Okay. So, given triangle ABC, prove the measure of angle A plus the measure of angle B equals the measure of angle 1. So, here we are. I have triangle ABC, right? So, we can look at, because they're a linear pair, angle 1 plus angle 2 is equal to 180, right? That's because a linear pair. I can also state that angle A plus angle B plus angle 2 equals 180, and that's oh boy, that's nasty looking little thing I just drew there. There we go, let's fix that. Okay, that's triangle angle sum, right? They add up to 180. Well, both sides of this are equal to 180. So angle A plus angle B plus angle 2 equals angle 1 plus angle 2. And that's by substitution. And then we're going to finish up by subtracting angle 2 from each side. So I've got angle A plus angle B equals angle 1. And that's just, I'm subtracting the same thing from each side, right? Subtraction, property of equality, or just subtraction. And I've proven the theorem. Again, you don't have to worry about the proof. I want you to be able to use the theorem. And that means I can add those two remote interior angles, and that will be equal to the exterior angle. So a corollary is a theorem with a proof that follows as a direct result of another theorem. And a corollary can be used as a reason in a proof. So we have some triangle angle sum corollaries. So the acute angles of a right triangle are complementary. That's easy to figure out because if I have a right triangle, I have one angle that's 90. And since all three angles have to add up to 180, the remaining two have to add up to 90. So that is an easy proof to figure out with just a little common sense. There can be at most one right or obtuse angle in a triangle. Since a triangle has three angles, if I have two right angles, that adds up to 180. The third angle is 0, and a third angle of 0 is not existent. So that doesn't work. If I have two obtuse angles in a triangle, well, both of those are greater than 90, and that means that I have two angles that add up to more than 180, and that does not make a triangle either. Okay, so let's do a little bit of calculation here with this. So I can look at this and I can see right off the bat that angle 1 plus 57 equals 180 degrees, right? So it's a linear pair. So I'm just going to take my calculator and 180 minus 57, and I've got 123. So angle 1 equals 123. Okay, we'll write it here as well. Okay, now figuring out angle 2, I'm going to use exterior angle theorem, and I'm going to say that angle 2 plus 71 equals 123. So using some basic algebra here, 123 minus 71 gives me 52. Okay. Now, I think the easiest way to solve for angle 3 is to use what we've learned already, which is triangle angle sum theorem. So we're say 123 plus 28 plus angle 3 must add up to 180. So I add 123 plus 28, and I've got 151 plus angle 3 equals 180. So I'm going to subtract 180 from 151, and I'm going to end up with 29. Now we take a look at example number 2 here, and there's quite a bit going on, and we've got a number of angles, but let's work out what we can. and see what we can come up with here, right? So I know two angles in one triangle. These two right here. I've got this 58-degree angle and this 65-degree angle. So I can use triangle angle sum theorem and my good old fancy calculator here to come up with my measurement, right? So I've got 65 plus 58, and that gives me 123. So I'm going to subtract 123 from 180, and I get 57. So I knock out a few angles with that because I've got, so if this one's 57 here, angle 5 is also 57 because those angles are vertical. I can also figure out angle 6, right? Because angle 6 plus angle 7 are a linear pair, or I can use exterior angle theorem. Either way, that comes out to 123. So this one is 123 right here. Now I want to figure out angle 4, right? So I've got 57 and 67, and I got to figure out angle 4. So 57 plus 67 is 124. So I'm going to subtract 180 minus 124, and I've got 56. So angle 4 is 56. So my only two angles left to figure out are angle 8 and 9. Well, I know these two are equal. So I'm going to make them both x, and I'm going to use algebra to figure out what that is. So I know that angle 8, which is x, plus angle 9, which is x, plus 123 adds up to 180. So I'm going to add angle 8 plus these two x's together, and I get 2x plus 123 equals 180. I'm going to subtract 123 from each side. I get 2x is equal to 57, right? So I'm going to divide each side by 2, and I end up with, and if I use my calculator, 57 divided by 2 gives me 28.5. So x is equal to, we'll say 28.5 degrees. So let's list them all here. Angle 4 is 56. Angle 5 is 57. Angle 6 is 123. Angle 7 is 57. Angle 8 and angle 9 are both equal to 28.5. Okay, we worked our way around, and we just keep plugging away and knocking out different angle values based upon these theorems. Okay, for example 3 here, we've got a lot of right triangles, and we're going to work with all the right triangles in this picture to figure out what these angles are. So we're going to be using the right triangle corollaries, right? One of the corollaries we learned is that the acute angles of a right triangle are complementary, which means they add up to 90. So to find angle 1, we're just going to figure out, we see we have a right triangle there that runs, this is the right triangle we're going to work with, this first one here, right? So this one right here, right? This one right here. And we know that angle 1 plus 52 degrees adds up to 90. So 90 minus 52 is 38. So this angle 1 is going to be 38 degrees, right? Angle 2 and 38 have to add up. Well, we notice here 52 plus 38, we can use this information right here. Those two add up to 90 degrees. So angle 2 is going to be 52. Angle 3 and angle 2 have to add up to 90 because of this here. So angle 3 is going to be 38 degrees. Now, since I have a right angle here, this also is a right angle. Since that's a right angle, this means that angle 4 and angle 3 are complementary, and that's going to add up to 52 degrees as well. So angle 1 is 38, angle 2 is 52, angle 3 is 38, and angle 4 is 52.
That's all, folks.